Hey guys, this is Mr. C, and in this video we are going to be solving some literal equations. A literal equation is an equation that has letters usually and some coefficients. Sometimes it's all letters. And a literal equation, they're going to tell you what variable they want you to isolate and to get by itself. And so it says solve the equation below for y. So our goal here is to get this variable right here by itself for whatever reason, all right? So what you're going to wind up doing is doing a bunch of opposite operations to get this unwrapped and get everything else on the other side. And so that variable hopefully will be by itself. So I'm going to give you plenty of examples here. And so here's your first one. And so we want to solve for y. And so since the 4x is kind of tying us up here, we want to go ahead and move that over. So I'm going to subtract 4x on both sides. The good thing is this over here, when you're just solving for y, I don't really have to have this in any particular form. So the minus 4x can go after the 12 if I want. It can go in front of the 12 if I want to put it there. And so I'm going to bring it down by 3y equals, and I'm just going to put it behind the 12 because it doesn't really matter. I'm just wanting to get y by itself. Now I need to get this y by itself, but I need to get rid of that 3 coefficient. So I'm going to divide both sides by 3. And now my answer is y is equal to 12 minus 4x over 3. That's fine. There's absolutely no reason why we have to split this up into two fractions and get it into any particular form, because the problem doesn't really say to do that. Now, if you were trying to solve for y to graph this line, then yes, then we would want to do something different. But if you're just plain just solving for y, I mean, just get y by itself, and whatever this side turns out to be, after you've unwrapped it, that's just what it's going to be. So I'm just going to go ahead and leave it like this and just be done with it. All right, our next one, you're going to get a bunch of formulas. And so this formula is actually the formula for the area of that would be a triangle, right? Based on site. And it doesn't matter what this is for, really. Our goal is to get h by itself. And so what I'm going to do is I'm going to unwrap this side over here to get the h alone. So I need to get rid of the 1/2 and the b. So to me, the first thing I want to do is probably multiply both sides by 2. And the reason why I want to do that is because I know that 1/2 and 2 are multiplicative inverses and they cancel out. So my next step is 2a equals, and then is bh. Now I want to get rid of the b because that's tying me up here. So it's being multiplied, and the opposite of multiplication is division. So I'm going to divide both sides by this b right here. Cancel those out because those are multiplicative inverses. And now I have 2a over b is equal to h. And so now h is by itself. Even though it's on the right-hand side, it's still by itself. And that's the main goal, is just to get the variable that you want, this guy right there, by itself, and it is. All right? In other classes, they'll tell you why you need to be doing this, like in geometry. But for right now in Algebra 1, we're just looking at the skills required to be able to get that variable by itself. And it's always going to be these opposite operations, and then maybe a couple other weird things as you get a little harder problems. So let's take a look at this one. I want to solve this equation for n. So I want this guy right there. I want that by itself. So I'm looking at this, and the 180 is tying me up here, not the -2. I want to save that. So I want to get rid of that 180. So what I'm going to do is I'm going to divide both sides by 180 to get rid of it. All right. This does not affect the parentheses. Only these guys are going to cancel because the 180 and the n-2 are both separate factors because it's in parentheses here. So now that's gone. I now have s over 180 is equal to, now there's nothing in front of the parentheses anymore. It went away. So I can take the parentheses away and just write n-2 right there. So now all I've got to do is just add 2 to both sides like that. And now I have s over 180 plus 2 is equal to n. And I'm done. Okay, the next example, another one from geometry. C is equal to 2 pi r, and it says I want to solve for r. I want that by itself. I can immediately divide both sides by the 2 and the pi at the same time. Pi is just a real number, just like any other real number, and it can be divided, no problem. These will both cancel, and now I have c over 2 pi equals r, and now I have an expression that has r by itself. So let's say I'm given the circumference of a circle and I need to know the radius. Well, this would be preferred because now all I have to do is plug that circumference in here, do my division, and I'll have the radius immediately. So that's one of the advantages of being able to manipulate these equations around to get a specified variable by itself. Okay, here we have one from physics. D is equal to m over v. D is density, m is mass, and v is volume. Not that you need to know that, but it might help. So we need to solve for v. So how do I get v by itself? I'm going to show you a little trick here. If you have one thing here and a fraction on the other side, you can take these two guys here and here, and you can swap places with them. And so you can immediately get v is equal to m over d. Now let me show you why that works the way it does. It's really a proportion, and what you're really doing is cross multiplying because there would be a 1 down here if it was a proportion. But even so, if you think about it, 6 divided by 2 is 3, isn't it? But if I switch the 3 and the 2, I get another true statement. And so if you switch these two around, you will get another true statement. And here I got the v by itself in one step. The thing you can't do though is you can't move the m. The m or whatever here is in the numerator would have to stay, but you're more than welcome to exchange these out as you want to. That's going to become very handy when you get to trigonometry. All right, let's take a look at this one. Looks like we got some simple interest going on here. And so we have interest is equal to principal times rate times time. Not that you need to know that, but we need to get the r by itself. So what I'm going to do is I'm going to kind of pick and choose here. I'm going to select the p and the t to divide there on both sides. And so now I can cancel those out like this. The r is still over here, but the other side becomes I over pt, and now I have r by itself. Again, all I'm using is opposite operations. There's no tricks, there's no fancy anything for these. Okay, here we have force is equal to mass times velocity squared over radius, and we need to solve for m. So these now are becoming very typical EOC questions. So I want to get that by itself. Well, the v squares hold me up, but the r is really holding me up. So what I want to do is I want to multiply both sides by r. And the reason why is because over here, that's the only way that those are going to cancel out. So now I have f times r, and from teaching physics so many times that I naturally put the r after the f, but it doesn't matter, is equal to m v squared, and now I have to solve for m. Well, there's still multiplication going on here, so now I'm going to divide by the entire v squared like this, cancel both those guys out, and I have f times r over v squared equals m, and now I've solved for m, no problem. M is now by itself. Okay, this one has the structure of the area of a trapezoid, and what they normally do on EOCs is they'll take the normal variables, like that would be the base, that would be the height, that would be B1, that would be B2, but they'll take the variables and they'll just switch letters out. They're just letters standing for something. And then they're going to tell you which one to solve for. In this case, it's Z. So I want that guy by itself. I got a lot of stuff here that's tying me up. And I always want to deal with this first before I start digging into these parentheses. So the first thing I'm going to do is I'm going to multiply both sides by 2. And the reason why is because I want to get rid of that 1/2. And I really hate dividing by fractions. I'd rather just multiply by the multiplicative inverse. So what I get now is 2a equals x times y plus z. So what do students always say now when I say what to do next? They always say distribute. If I distribute that x, I'm not going to help myself out at all. So what I'd rather do is just divide both sides by this x right here to move it over underneath like this. And what I get now, just to save some room here, 2a over x, and you can watch this video several times and stop it and pause it, just to, if I'm going too fast, is equal to, the x is gone, parentheses now go away, y plus z, and now all I have to do is move the y over. And since it's a plus y, a positive y, I need to subtract it on both sides. So now my final answer would be 2a over x minus y equals z. Is that the only possible answer you could get for this? No, there's other ways you could do it. If you had distributed, then it'd take you probably another extra step. This would look a little different because you'd have a common denominator here. However, it would still be equal to z, and this answer right here is good to go. That's probably the easiest way to go on that one. So trapezoid formulas are very common on standardized tests. All right, this one, I want to solve for x, and there it is right there. I've got the b there, I've got the -1, but I've got this a sitting there. And it's not a plus b, it's a plus all of this. So the first thing I want to do is I want to get rid of that a right there, because that a is holding me up from being able to get this out. So I've got y minus a equals b times x minus 1. All right, now I want to get rid of that b right there now before I start digging into the parentheses. So now I'm going to divide both sides by b. Those cancel. And now I have, let me save some room here, y minus a over b equals, again, everything went away, so the parentheses go away too, x minus 1. And after you've seen a few of these, you can kind of predict what you're going to do next. If I want x by itself, I just have to add 1 to both sides, like that. 1's cancel, and now I have y minus a over b plus 1 at the end. I don't want to add it up just up here, it's added to the whole thing, equals x. And now x is by itself. And it really does just take a few seconds to do these once you get the hang of it. Okay, here we have a proportion. We have a over b is equal to c over d, and we want to solve for d. So let's go ahead and cross multiply and see how that works. So we're going to say a times d, we'll say equals ad is equal to, I should put an arrow there, right? Because there's the equals. And then b times c. Okay, so what that does is it gets rid of my denominators here. And now I need to get d by itself. So all I've got to do now is just take both sides, get the a gone there, cancel those two a's out, and now my final answer would be d is equal to bc over a. Again, is that the only way you could do this? No, there's other ways you could do it. But to me, in my brain, since I've done so many of these, that's just the way that comes natural. And it's really not that difficult. All right, let's take a look at this one. The area of a circle formula. A equals pi r squared. And we need to solve for r. So first thing we need to do is get rid of that pi that's sitting there, holding us up. So we're just going to divide that on both sides. Cancel those guys out. And so we have a over pi is equal to r squared. So now I have a problem. It's not r, it's r squared. So how do I get just a plain r on both sides? Well, the only thing that's going to kill off this square is a square root. It's the only thing that's going to get rid of it. So I have to take the square root of both sides like that. Now, as we've seen in other videos, especially with rational exponents, a square and a square root are inverses. They cancel each other out. And so now I have a over pi square root equals just a plain r now. And that would be the final answer for that one. Okay, so here we have another physics formula. And this time we want to solve for k sitting right there. And we got all this stuff. And we either have multiplication or division going on. I'm going to deal with this r squared first. So I'm going to get k by itself. I'm going to take the r squared and I'm going to put it over here by multiplying both sides by r squared, just like that. So these guys are going to cancel out, and I'm going to get f r squared equals k x, y. Now I do want to get k by itself, and it's being tied up with multiplication with these two guys. So now I'm going to divide both sides by the x and the y, and that's going to move them over underneath the fr squared. These will cancel out, and I'm going to get fr squared over xy equals k. Now, when you get to be a junior or senior and you take physics, your teachers or your professors in college are going to do this very quickly if they even do it at all. They're just going to write this down on the board because they already know what k is equal to. They've already moved the stuff around in their brain. And so you're going to have to you might have to like catch up a little bit to figure out how they got the k by itself. But if you have a good handle on this now, then that won't be as bad. Trust me, I know that's what happened to me. All right, here's a very useful one. Here we have the formula that converts Celsius and Fahrenheit. Here, if I plug in a Fahrenheit degree measure, I'm going to get a Celsius measure back. And so what this is going to do is this is going to allow me to be able to plug in a Celsius and get the Fahrenheit back. So I want to get F by itself, Fahrenheit. So what I want to do is get rid of this 5/9 first. And so to get rid of that 5/9, I'm not going to divide by it. I'm going to multiply by the reciprocal, which is the multiplicative inverse. I want to use that language as much as possible so you get used to it. These guys, even though they're not right next to each other, they cancel out because multiplication is commutative, and so these two can be swapped, and these two guys are going to cancel each other out. They're going to make 1. So I have 9 over 5 c equals, now everything's gone, f minus 32, and now all I've got to do is add 32 to both sides. Plus 32, cancel those out, and so now I have 9/5 c plus 32 is equal to f. And there you go. Next one we've got, let's see what this one looks like. Oh, good. We've got the period of a pendulum. All right, so t is equal to 2 pi times L over G in a square root there. So we want to get L out of there, extracted. All right, so the first thing I'm going to do, and after a while, I'm going to start kind of doing this, like this. The 2 pi has to go, okay, because that's, first of all, holding me up here before I start digging into this square root. What's going to happen is this 2 pi is going to go underneath the t when I divide it, right? So I already know that that 2 pi is going to go under there, and that's equal to the square root of L over G. So notice how I didn't show that step, the division, because that would be really awkward because I don't have a lot of room down here. But that's what's going to happen, and after a while, you get used to this, and you'll be able to do this easily. Now, what I want to do is I want to get rid of that square root. So how do I get rid of a square root? Well, I've got to square both sides. And so what I'm going to do now is I'm going to square both sides. If I square both sides, I've got to be careful. I'm going to get t squared up here over 2 squared is 4. Pi squared is just pi squared. Just leave it like that, is equal to L over G now. So now they're unlocked. But I want to get that G out of there. So now what I do is I multiply both sides by G to get rid of it. And so let's see how that's going to work. So I'm going to multiply this side by G and this side by G. Now I got to remember, these guys are going to cancel, no problem. That G is going to go with the numerator if it's on the side like that, isn't it? Right? So that G is going to go with that t squared right there. So what I'm really going to do is I'm going to have G t squared, and you can put t squared G if you want. It's commutative, over 4 pi squared equals L. And I didn't know how handy that was until I started teaching physics and taking physics, and being able to manipulate these equations to put them into a calculator to get a decimal answer is very, very helpful. All right, here we have a familiar one, and that happens to be the formula for slope. And so it's asking us to get this guy by itself for some reason. All right, so we need to get that guy by itself. What I'm going to do here, I'm going to do something interesting. I'm going to take this whole thing and I'm going to switch places with the m. I'm going to swap those out. And so what I'm going to do is I'm going to write x2 minus x1 equals y2 minus y1 over m. Okay, so am I allowed to do that? I most definitely am allowed to do that. I can take this whole thing, denominator, and take the m and swap them out, as long as neither of those is 0. So here's what I have now. Okay, so now I need to get that x1 by itself, don't I? So I'm going to do something kind of nifty here. I want that x1 to be positive. I really don't like for that to be negative right there. So what I'm going to do is I'm going to take this side, I'm going to take the x2, and I'm going to switch places with them. And so when I do that, I'm sorry, not the x2, the x1. When I do that, when I switch places with these two guys, right, I'm going to get x2 minus y2 minus y1 over m equals, and I'm going to move the x1 to the other side, and now I have an equation where x1 is by itself. And that's perfectly fine. There are ways that you can deal with this. You could absorb it into the numerator and switch these two around. I don't want to get into that because that's better off looked at in the classroom where people are going to ask questions. We can just leave it like this and understand that x1 is now by itself and we're good to go. All right, let's try this one. Okay, so we have v is equal to 1/3 b squared h. And so we want to get b by itself this time. There is a square with it, no worries. Okay, so if you've learned some things by now, we want to get rid of that 1/3 by multiplying both sides by 3. And so that guy and that guy cancel. And so now we have 3v is equal to b squared h. Next thing we want to do is get rid of the h. So we divide. Why do we divide? Because that's the opposite operation of multiplication. Cancel, cancel, and we get 3v over h is equal to b squared. But that's not quite good enough because we want b by itself, not b squared. So we still need to get rid of that square by taking the square root of both sides, like that. Now we have the square root of 3v over h, all of that equal to just plain old b right there. Okay, next example. Very similar, but this time we have v is equal to 4/3 pi r cubed, and you see I like using geometry formulas because they're very common. And so I want to get rid of the 4/3 first, and I'm going to go ahead, and actually I don't really have to do that. I can just do this. I can really just multiply both sides by 3, cancel those two guys out, and now I have 3v equal to 4 pi r cubed, because that 4 is in the numerator, and so is this. Now I want to get r by itself, so I'm now going to divide both sides by the 4 and the pi to get rid of those two guys, like that. Cancel, cancel. Okay, so here's where I am now. 3v over 4 pi equals r cubed. All right, so here's the next question. How do you get rid of a cube? Well, a square root gets rid of a square, so a cube root gets rid of a cube. They are inverses. And so we put a little 3 up here, and that's the index. And so now we have the cube root of this whole thing, 3v over 4 pi is equal to r. And that would give us the radius of that sphere when we have the volume given to us. So that one's actually not too bad. It's a lot like the last one. This one is great because this one stumps students all the time. I'll ask them to get the x or y by itself, and this time I'm asking for y. And they look at it, and even in Algebra 2, they will sometimes be absolutely stumped. So I'm going to show you a little trick here, and here's my little trick. I want to get y by itself. I have two terms here. It's going to do me no good to divide everything by y. It just is not. I'm going to have an issue over here. Y is not going to be by itself. So what I really want to do is I want to factor a y out of these two terms. So what I want to do is I want to take this x equals, and I want to factor a y out by writing y times. Okay, so if I take a y out of here, I have an x left. If I take a y out of here, I'll have a plus 1. And now, if I divide both sides by y, not y, x plus 1, like this, these two guys cancel, and I get x over x plus 1 is equal to y. And now y is by itself. So if there's more than one term with a variable in it like this, generally there's going to be some kind of factoring going on. And those are ones that you just have to see a lot of examples of until you get a really good grasp of it. Okay, here's a good one. And so here we have, it looks like the surface area of a cylinder. And so, not that it matters, but we want to get h by itself right over here. Now, there's a couple things I could do. I could factor a 2 pi out of both of these, actually a 2 pi r if I wanted to. If I want to do that, I could, or I could move this term over like this, minus 2 pi r squared. I could do this, just depends on your teacher. Those are the exact same terms, so they cancel out, and I have a minus 2 pi r squared equals 2 pi rh. Now, if our whole goal is to only get h by itself, like I said, it really doesn't matter how you do it. You just have to get that variable by itself. I can now take both sides and divide by 2 pi r, all three of them. All three of these guys cancel over here. And I now get a minus 2 pi r squared over 2 pi r equals h. And that might be a monster to put into a little calculator like this right here, but it's better than nothing and it can be done. You're just probably going to get some kind of a decimal answer unless you get an area that has pi's in it or something like that. All right, last example. This one comes from physics, and this one is the formula to calculate the total resistance of two resistors that are in parallel. It also resembles a lot the formula for an optics called the simple lens maker's equation, but our goal here is to get this R by itself, capital R. So how are we going to do that? Well, we don't want to start moving stuff around here. What we want to do is combine these two fractions into one fraction so that way we can flip them. And so if we take these two fractions over here and we use our butterfly method, we will get 1 over r equals 1 times y is y, 1 times x is x. So that will be x plus y over x times y, if you remember that. And again, they call it the butterfly method because really what you're doing is this, this, and then this to add two fractions together. All right, so where are we at? We have a 1 here. And so one nice little thing you can do with proportions like this is you can take both sides and flip them. And so you can put r over 1 equals xy over x plus y. That's completely legal as long as you don't have anything making 0 in the denominator. So now our equation, if we want to get rid of that 1 right there, would just be a single r equals xy over x plus y. They love to give you ones like this, problems like this on the EOCs, just because they're difficult, and see if you can handle it. And that's how people make 4s and 5s, because they can take an equation like this and they can unwrap it and use these little mechanisms to get that variable by itself. And it's really not that bad. You just almost something you just have to practice. But that's about it for literal equations. There are many, many more formulas you can solve for variable, but these are the most common ones, and they also show you the most common solution methods, which is just basically either factoring every once in a while or just using opposite operations. So hope you enjoyed it. Remember to like and share, and subscribe to my channel if you haven't already, and we will see you guys later. Bye-bye.